Let's talk calculating KSPs and molar solubilities. So depending on what the compound is, you are going to have different relationships between the molar solubility and the KSP value in terms of X. So something like, let's say, silver fluoride is going to dissociate into two ions. It's going to make a silver ion and it's going to make a fluoride ion. And so when you go to calculate KSP, the KSP expression would be KSP equals your concentration of silver ion times your concentration of fluoride ion, and they're going to be equal to one another. So if X amount of silver fluoride dissolves, you'd make X moles of silver ion and X moles of fluoride ion. So you can plug in X for both of those, and KSP would equal X squared, where X equals the molar solubility. If you were using a different compound and it was dissolving, let's say, what's a good one? Let's go barium hydroxide. And that should have been a double arrow. All right. So barium hydroxide dissociating, you are going to get a barium 2+ ion and 2 hydroxide ions. Then when you set up your KSP expression, it would be KSP equals the concentration of barium ion times the concentration of hydroxide ion squared. Then if you think about it, if X amount of the barium hydroxide dissolves, you're going to get the same amount of barium ion, but you would get 2x of the hydroxide ion, because for every one barium hydroxide that dissociates, you get 2 hydroxide ions. So then our KSP expression there is going to end up being KSP equals X times 2x squared. And so if you expand all that out, that would be X times 2x times 2x. And so for something that dissociates into 3 ions, KSP is equal to 4x cubed, where X represents, again, the molar solubility. So it just continues kind of along that path. One of the more complicated ones, I suppose, would be, like, let's take lead 2 phosphate. So if you had lead 2 phosphate, that would be Pb3 PO4 2. When that would dissociate, it would yield 3 Pb2+ ions and 2 phosphate ions, so that your KSP expression would equal your concentration of lead cubed times your concentration of phosphate squared. And then in terms of X, when X amount of this dissolves, you're going to get 3x of the lead and you are going to get 2x of the phosphate. So when we plug that into our expression, KSP is going to equal 3x cubed times 2x squared. And so KSP here would equal 3x times 3x times 3x times 2x times 2x. So that gives us x to the 5th, and then 3 times 3 times is 27, 54, 108, 108 x to the 5th where again, X equals the molar solubility.